Okay, well, welcome all to this demonstration of the Phillips machine. It's a fabulous pleasure to demonstrate this. It is a thing of wonder and joy, and I would give this talk to an empty room. It is a brilliant machine. A privilege for me to work with it. My name's Allan McRobie. I'm an engineer, not an economist. I understand there's a few economists here. Put your hands up if you're an economist. Are there any economists here? Okay, because I might need to ask you some questions as we go along. I have my helper, my beautiful assistant Tom here. Tom starts work at the Bank of England on Monday, so I'm going to show him what happens if you have a big government spending cut. So I'll start with the machine first. Here it is. I'll switch it on in 1 minute, but first I'll just give you the geography of the machine. It starts at the bottom with a great big tank of water. All the money, quantity theory of money, is in that tank of the water, and it flows out of the side of that tank of water at the bottom through a thing called the Sutro weir. And I've drawn it over here. It's a funny little slot that's sort of 1 upon square root shaped slot. A weir normally has a non-linear head-discharge relationship, but here Phillips has very cleverly made something that's got a linear head-discharge relationship, so that the height of water is proportional to the flow there. And that, in the quantity theory of money, I think his income is proportional to M1, I think it's called, the total amount of money. It might not be M1, but anyway, the total quantity of money in the economy, which is the Cambridge equation, I believe, which is down here, the linearity between quantity of money and national income. So it flows out of here. It then goes round a pump at the back. We think it's a pump off a Lancaster bomber. It was common in those days in the 50s to scavenge MOD equipment after the war. Very common, lots of people did it. So there is a bit of MOD equipment. And then it comes up here. So this is national income coming up the side here. Comes in at the top here. One of the two certainties in life is tax. So it comes off to taxation this way to the government. So the government is over here. Income after tax comes down here, and this splits into consumption, and apparently some people save. So that goes off this way to the Bank of England over there. So we've got the bank, the high street, and the government there. So he's even got the geography of London right, if you think of Westminster, Oxford Street, and the city over there. The bank doesn't just keep it stuffed in a mattress. People borrow it to invest. The government likewise spends it. These three flows come down together to give you a total domestic expenditure. Some of that we spend on imports. So again, the geography is right. If you think of that as a Channel Tunnel or Felixstowe, you've got Belgium over here, imports, and then money comes in from exports this way. They all join back together and they go down to the bottom there. And I've drawn it over on the board here. So if you can just see this, can we just shift this back slightly, Tom? Just to remind you, it's the basic roadmap of the national accounts, sort of A-level national accounts. So out of here, Cambridge equation, up there, tax to the government, savings to the bank, consumption, they all come together, imports, exports, like so. The bank is a stock. There's the total quantity of money over here. There's also the Royal Mint. The Royal Mint can print money to keep the level of water in the bank constant. And also the government can borrow. And so this is really I think it's called the public sector borrowing requirement, comes over this way. So you can run a budget deficit by borrowing, competing in the market for loanable funds to do that way. It's sort of hidden around the back of the machine, and economists think this is funny. Yeah, because you can't see what the government's doing. But that's this sort of little pipe. You can just see it at the back here. There is a little sort of telltale here if you look closely, but it's fallen off, which shows you whether the government's borrowing or not and running a budget deficit. So that's the roadmap. Except that's the roadmap of money. For the very first, it occurred to me, I'm an engineer. Economics, I learned, is about goods and services, not about money. So goods and services flow the opposite way to the money. If you give someone the money, they give you the goods or the services. So goods and services flow this way. So the imports, the Belgian chocolates, come in from Belgium and go up to be consumed on the high street like so. And production is sort of right down at the bottom of the machine. So he's got the geography wrong here, because in the 50s everyone knows that the wealth of the nation was made in the north and spent in the south, but he's actually got it made in the south there. But apart from that, the machine is geographically correct. So I'll switch it on now and we'll settle on at equilibrium. So we'll do a couple of experiments today to show some of the basic sort of Keynesian macroeconomic mathematics. There are lots of metaphors about water and economics. There's sort of liquidity, there's income streams, there's cash flows. But this isn't a metaphor, this is an analog. It's a quantitative analog. And if I've got it all working right, I should get within about 4% of the correct equations. Whether the equations are models of the economy is a different matter, but I can, using Phillips Machine, solve those equations to within about 4%. So we'll work on going towards a simple Keynesian multiplier. The very first one is a Keynesian multiplier. We'll get to that in a minute. I'll just settle it down to an equilibrium. First thing we're going to do is balance the budget. Quite easy. So easy. How hard can it be? Okay, so that's budget balanced. One of the key features of the machine are these little sliders, little graphs here, little perspex sheets with slots in, and those little slots carry a pin. And that pin, so if this graph goes up and down, like so, you can see how the pin moves this slider back into, and that constricts the waterfall. So that's how he controls things here. And what I'm going to do today is shut down the foreign sector completely, and we'll just look at the interaction between, and I'll just keep the budget balanced. We'll just look at the interaction between the high street and the bank today in these very simple first experiments. So I'll just let that settle to an equilibrium. And the equilibrium I'm aiming for is a sort of 1, 2, 1. So it's 4 in whatever units, 4 billion a year, trillion a year. Let's say just 4. So 1, 2, 1 through here. And so this graph here, which is powered off a float on the tank at the bottom, because of the linearity of the Cambridge equation, that height is proportional to income. So if I measure that height, I know what the income is. So this height, powered by that float via all these pulleys, gives you income. Okay, so this should settle down to about 4 here, and we should have 1, 2, 1, like so, there when it settles down. And then we'll have a look at a Keynesian multiplier. I'm not an economist, but I'm told that Keynes and Robertson had big arguments about what set interest rates, and if they'd lived to see Phillips' solution to this with this implementation here, apparently they would never have argued, because this is sort of, if you look at it one way it's Robertsonian, but if you look at it another way it's Keynesian. But I don't fully understand that part of it. But I will just explain the bank, and I've got this diagram over here to explain how the bank works. It's basically supply and demand of a stock. So you've got some stock of loanable funds here, you've got a float on it. So as this stock goes up and down, these graphs are connected to it, so they go up and down as well, and the little slots with the pins and the sliders constrict or destrict the supply and the demand of the funds, like so. So if the stock is low, this has come down, so the price is high, which therefore, if the price is high, demand gets shut down and supply gets opened up, like so. So that's the basic supply and demand. So think of this now as a stock of rates this way, and if we take those two curves here, we've got the basic supply and demand curve. We should hopefully, it will settle down to an equilibrium, which is what I'm aiming for over there. So if there's a high price, you've got a low demand and a high supply, like so. Supply and demand of loanable funds. And this sort of inverse relationship, so if the stock is low, the interest rates are high. There's a sort of reciprocal relationship between how much money is in the bank and interest rates. And that governs the savings and investment. So this is savings, this is investment. This is supply and demand. And this is your liquidity preference function, which gives you the relationship between the two, I believe, which is the side of that tank, which gives you the sort of inverse relationship, which we can see over here. So I'm getting pretty close to my equilibrium. I'll just put the pen plotters on. It does plot graphs as it goes, which is rather nice. So the one over at the right here plots interest rates. So interest rates are currently about 5%. That's powered by a big float on the tank, or the inverse relationship via a pulley up there plots interest rates. Now I'm going to peg interest rates via the Royal Mint. If I keep this constant head device open at the side here, that'll keep the quantity of water fixed. So we're not working with a fixed quantity of money, we're working with a fixed interest rates. So the first experiment we're going to do is the Keynesian multiplier, which is where the economists can help me to explain how it works. It's the magic of economics. What I'm proposing to do is make a $1 billion a year increase in investment. So we go from 1 to 1, we'll go to 1 to 2. So we should go from 4 to 5. But we don't go from 4 to 5. We add 1 and we get 6. 4 plus 1 makes 6 in economics. Via the Keynesian multiplier, via this thing here, which is your propensity to consume curve. The simplest I've heard it explained is that if you make the one investment, the butcher pays the baker, pays the candlestick maker, and it goes round, and so you get more for your money. So I've got this propensity to consume curve. It's got a slope of about 2 at the moment, which means basically you spend half and save half of your net income, which is powered by this here. And I've taken all of the other graphs out, all of the other little sliders to keep it simple. So I've got taxation, there's no taxation rate. We're just going to have the billion and a billion here. And every other graph is out except for propensity to consume, and that's all shut down. So I'll just settle on at equilibrium. I think we're just about there. Just above 4 on the graph. I'll just get a little steady trace and then we'll see what happens. Sorry? No, I wouldn't. It's okay. Okay, interest rates are 5%. They should stay constant over here. This is now coming along nicely, just above 4. So now I've got my 1, oh, slightly above 2. Let's just get this to 2. Let's settle nicely on my equilibrium, and then we'll do the experiment. As the head of department said, Phillips was an amazing guy. He grew up in a farm in New Zealand, a real hands-on person. You get up in the morning, you fix the electric fence, that sort of thing. He then travelled to Australia. He became a gold miner, a crocodile hunter, banana picker. There's a number of these things. All the time training to become an electrician. He then set off to get his way across to Europe, and the Second World War broke out. He was a war hero. He was shot down over the Coral Sea somewhere, landed in Indonesia. He was going to do one of those scrap heap challenge things. He was stuck in the jungle. He found a coach, and they thought if you turn it upside down, you've got a boat, and then you can sail it back across the Timor Sea back to Australia. He was betrayed, though, in the process of doing this, and he ended up in the prisoner of war camp at Bandung. And if you read the books of Lawrence van der Post, there is this character in the books, this amazing New Zealand guy who could build a radio out of a paper clip, and some things they stole from the commandant's office, etc. And very, very scary. They had to hide the radio in the chair leg, and the commandant, or whatever his name is swinging back on the chair. And if they find it, you know, they cut your head off. Really sort of scary. The Japanese couldn't understand why at 10 o'clock every night all the lights went down in the prisoner of war camp. And it was because Bill Phillips was making 2,000 cups of tea for all the prisoners. So he's an amazing guy. Right, we're ready. Well, there's the 4. We've got a nice straight 4 trace there. So now I'll start the experiment. Okay, 1, 2, 1. And I'm going to push this up to 2. So according to the prediction, we should go from 4 to 6 here, because the slope of the marginal propensity to consume is 2. So the multiplier theory says it should be 1 over your propensity to save. Propensity to save is 1 over a half, gives you the 2. 1 over the propensity to save, which is a half, gives you the 2. So we should get a multiplier of 2. This should go from 4 to 6. It's already rising beautifully. You can see over here. Oh, sorry, I just knocked it then. No, I didn't mean to. It should go up to a nice sort of exponential growth to 2. Give the game away, we should get that curve. This is the curve we did when it was the 100th celebration of the Cambridge Tripos. That was the sort of inaugural launch date, and Sir Edward George, a lot of famous alumni were here, and we gave it the inaugural run. And those were the curves we got that day. I can since get better curves, much more accurate curves, since I've been playing with it. So it's a linear system, so we're going to get an exponential growth. Right, we'll leave it to do that. While it's doing that, we should see the nice, beautiful exponential curve happening up here. Should go from above 4 to just above 6 there. So he was finally liberated from the prisoner of war camp. He finally made his way across to Europe, got to London, and he decided he didn't want to be an engineer anymore. He wanted to study sociology, to study man's inhumanity to man. How could he explain all the things he'd experienced in the prisoner of war camp? And he joined the LSE studying sociology. By this time he was a real heavy chain smoker from his prisoner of war experiences. He was just about to be thrown out. I think he was getting a pass degree in sociology. I don't know if it's because he couldn't sit through an exam without going out for a cigarette and not coming back in, but it wasn't even a third. I think it was a pass degree in sociology. And just before they were about to throw him out, he went to see his tutor and he said, this economics module I've been studying, I don't understand economics, but I do understand plumbing, and it looks to me like your two equations are the same. The sets of equations are the same, and I can make a model out of plumbing gear to solve your equations of economics. And to the eternal credit of this tutor, the tutor said, go on then. Because I know what I'd have said if a student, a pass degree student, had said that to me. But he did. So he and Walter Newlin, the other sort of hero of this story, in a little garage in Croydon, there's a picture of them at the back there, they cobbled together the first one, the Mark I, which was really just the top half. Since then they made lots of these. This is a Mark II. When I say lots, 14 were ever made, we understand. There's one in the Science Museum. That was the LSE original. LSE gave theirs to the Science Museum. And because of that, we could renovate this one. I renovated this one in 2003. There's always a dynamic tension between conservation and restoration if you've got an object of historical significance. But because there is a completely perfectly preserved one in the Science Museum, the economics department here decided that it was legitimate to have a living one. So I renovated it here. The first thing we had to do, you may notice, are these danger 240 volts stickers on it here. It used to be the case that there's certain water level detectors in here. It used to be 240 volts straight into water. It used to go boof, boof, boof to detect the water level with steam coming off. And you can't run it in today's health and safety legislation. You can't do that. So we had to step that down to 20 volts. So that was the first thing we did. So now we can run it. But apart from that, really, we haven't made any intervention in it at all, other than just connect all the pieces the right way again. So the only thing we've done is step that down to 240 volts. Here you can see the beautiful exponential curve. If you can see, it's rather faint, but you can come and see it afterwards, going up to just above 7. A lovely exponential growth. Keynesian multiplier is 2, which is the reciprocal of 1 over that slope. So we'll just let that steady off. Interest rates haven't changed because the Bank of the Royal Mint can keep printing money to maintain the stock at the same level in the Bank of England. So where was I? So why would a qualified electrician put 240 volts straight into water? I wondered about this for about a year while I was working on fixing this machine. Why would a qualified electrician do that? Any ideas? This is only a theory I have. Sorry?
Make an impression.
Keep people from messing with it, yes. Get rid of some top economists. I think the answer is that, how do you think he made the 2,000 cups of tea? That he probably just put that straight into the water to make the 2,000 cups of tea. And if you thought that was dangerous, you haven't lived in a prisoner of war camp. Because that's not dangerous. The dangerous thing is hiding the radio in your chair leg, etc., etc. This is not dangerous. So that's why I think he was quite happy. That's not dangerous to Bill Phillips, as far as he's concerned. So, but health and safety legislation doesn't agree. So we did that. Savings. Savings do change, but because I'm printing or burning, do they do that? Does the Royal Mint burn money? There's too much of it. Printing or burning money to stabilise that has no effect. So I think there is a change, but it basically goes off there, and whatever goes down there doesn't matter because I'm maintaining that water level constant. So I'd imagine savings probably went up, but it doesn't matter because I'm printing money from the Royal Mint. Do they burn it? Does the Royal Mint burn money if there's too much of it? Yeah? I don't know. Sorry? Well, what do they do? Because I can print or burn here. Do they? Okay. All right, so we're settled in that equilibrium. There's a nice demonstration of the Keynesian multiplier. I'll move this back now over here. I'll slide this over here, and I'll repeat the experiment, but going down. Now, so that's just about settled to an equilibrium up here, like so. And what I'm going to do is reverse that. I'm going to slide this one back. And what we should do is come down exactly the same curve, but in the opposite way. It's a linear system, so you just get the reverse exponential curve. But this time, I'm going to do it differently. This time, I'm going to work with a fixed quantity of money. So, first thing I'm going to do is turn off the Royal Mint. So I close that. That, I understand, is monetarism. So now we're going to work with a fixed quantity of money and repeat the experiment. So we're now at just above 7, and if I now decrease this back to 1, we should start to get a fall, but it shouldn't be as dramatic. Now this is the hard thing to explain. This is, yes, stop, whoa, thank you. I forgot to connect a key thing. Thank you, Tom, my beautiful assistant. We'll just let that go. Let's just think through the experiment. I'm going to decrease investment here. So I decrease investment, so the stock of money is going to rise, so interest rates are going to fall. And as interest rates fall, people are going to want to invest because there's low interest rates. So via this graph here, this will then reopen that valve that I've pushed. So I'm shutting it, but that will change the stock of money, which will affect interest rates, which will then affect investment behaviour, and that will erode into it. So instead of getting the billion a year decrease, I'll start to erode into that, and it should start to come back from there. So that's the experiment I'm going to do, and I just forgot to connect this graph here. So thank you, Tom. Right, so we're still at our original equilibrium. Now I've connected this graph powered by this float on interest rates, which should change that behaviour. So I shut that by $1 billion a year, from 2 back down to 1. And what I predicted will happen is that interest rates will fall, which we should see over here. Yes, interest rates are starting to fall now on this graph. Forget that little glitch, that's where I forgot the script, but it's now starting to fall, and as it falls that should make people start to invest more. It is starting to open up here. We've now got about 1.1, it should go up 1.2, 1.3, etc. So it's eroded into that. I think it's called crowding in a certain sense. Crowding out is when you make government investment and it affects private investment, but I think this is a subtle way of crowding in, if that's a phrase. But anyway, it sort of erodes, and we can see that this is opening up here. So the initial shock has been eroded into, and we're not going to come down as fast, is the prediction, because of this. And it would have to wait a very long time. This is the day we did it with for the Alumni on the 100th year, and you can see that it doesn't fall anything like so dramatically as it rose, because we're working with a fixed quantity of money. So only 14 of these were ever made. LSE had 2. Once they connected the 2 together, they connected the exports and import pipes. So one was the rest of the world and one was the UK. And there is some nice video, black and white video footage of, I think it's James Mead demonstrating that one. The Ford Motor Company got one, the University of Manchester, maybe Yale got one, Harvard perhaps, London, Cambridge, Leeds. Leeds got the original, the Mark I. In fact, Willie Brown is here, whose father, I believe, signed the petty cash docket to pay for the Mark I original for hydraulic computer 15 shillings and sixpence or something. And that one is now up in Leeds, and they've £100, yes, okay, £100. There we are. Now, that's up in Leeds at the business school, the Mark 1, but it doesn't work, and nor should it. It's an original historical item. This is a Mark 2. The Mark 1 doesn't have all the foreign sector, and there's a completely different system up here. I've been to see the Mark 1, and I met Doreen Newlin up there, the widow of Walter Newlin, who built the Mark 1 with Phillips, which was fabulous. So it's come down. You can see it's sort of leveled out now. It hasn't come down by the same amount it went up, and that's because we've the effect of having the variable interest rates with a fixed quantity of money. So I think that's that point demonstrated. So what I'll do now is there's another feature I do want to show you, which is a thing called the accelerator. So I'll consider that experiment finished, that we can see it's different whether or not you have fixed interest rates or not. And we'll now go down to, I'll reset it all to a new equilibrium. So first thing I need to do is turn the Royal Mint back on. If I go for I'll run a balanced budget of 2, 1. I don't need this in because interest rates are going to be pegged. And we'll settle to a new equilibrium, and I'll do this experiment with the accelerator. Now, the accelerator is a model of sort of human optimism. It is modelled by a hole in a bucket. There is a bucket that floats on the bottom tank. The bucket floats on the bottom tank, but the bucket has a hole in, so it doesn't completely, it sort of lags behind what the thing's doing. If there was no hole, it would just do that, but because of the small constriction, it lags it. And this essentially gives you a second order differential equation from a first order, because now you can tell whether, if there's a difference between those two, whether the market is rising or whether it's falling, like so. And so using that differential, powered by this bell crank here, we can then use that consumers' expectations, investors' expectations, to adjust investment expenditure, like so. So I'll connect that in a minute once I've settled back to a nice equilibrium. And essentially I'm going to repeat the very first experiment, the basic Keynesian multiplier experiment, but with the accelerator built in. What if human optimism recognises that the market is rising and then starts to invest more? We should get more and more investment, like so. The economic basis of this, I don't think the accelerator multiplier model has got much credence in economics these days, but the basic idea is the difference in these two water levels, I think, is proportional to capital, which is the machinery stock in your manufacturing industry, in the days when we had a manufacturing industry. So, and it uses that capital stock. It's trying to get the optimal capital stock at all times. So let's just settle back on my equilibrium and repeat that experiment. So it should be after a 1, I'm going to run 2, 4, 1 is what I'm going to do. A 7 this time. The government's going to have 2, consumption has 4, and 1 going through this way. And I'm going to make the slug, the increase, the increment, the shock of investment from 1 to 2. And again, we should see the Keynesian multiplier give us a factor of 2, except with the accelerator we'll get more than a factor of 2 is the prediction. So we're travelling along here at 7. I think we're pretty much at our equilibrium now, 2, 4 and 1. So if I do this very carefully, I've got to just think for a second because I have to get this right. Have I forgotten anything? Is that all right? So I just I'll shut this down. So I constrict the hole, then 1.5 turns, half, 1, 2, 1.5 turns on the accelerator. So this bucket via this fishing line will power this bell crank. You can see the bell crank there to open this investment valve. So I put that onto there. I'm pushing it up from 1 to 2. So that's it there, 1 to 2, but with the accelerator connected. So the prediction now is it'll give us more than the already magic 2. We should get even more than that. And you can see it started to rise already. It started to rise very, very sharply here. what we should see is this bell crank start to move and open this even more, because people are detecting that the market is going up, and so it started to open more investment. People said, hey, boom times ahead, good times ahead, let's invest. And that's what's happening over here. 2.3. People are very optimistic. It also works in the other direction as well, which is possibly what I should have done in this these circumstances. Sorry?
It's more what happens if the banks...
What happens if the banks refuse to lend?
Yeah.
Yeah, well, that's right. Well, we just shut this down, essentially, and the thing collapses. And if you shut the government expenditure down at the same time, it collapses according to this model. I can quite easily demonstrate what happens here, and it is this graph upside down with pessimism, and it just goes down, down, down. Sometimes when I'm talking too much, the machine runs dry in the background behind me when I'm demonstrating to kids. And I say, it's all right, I'll just print some money. And they say, no, remember Argentina, remember Zimbabwe, remember the Weimar Republic, because they're doing A-level economics. And I say, no, it's fine. And these days I understand it's called quantitative easing, so I can just, it's just quantitative easing, and we get the thing going again. So here you see it's fabulous growth here now. Really stupendous growth because of this. And if you look very closely, you probably can't see from the back, but there is a difference in the water level between the two buckets. And that difference in the water level, I think, says that there's a capital deficit, and it's trying to catch up with what's happening. So people are investing more to make up this capital deficit till it gets to the top. So I'll leave that going. I think I've demonstrated how the accelerator works, but what I want to do is just leave it going in the background. And I've never done this in public before, but I was playing with this over the summer. Because what I think, at this point, I normally switch the machine off and tell you a few more things about Phillips. What I'm actually going to do is leave it going, because I believe there's a chap called Goodwin at Peterhouse who did some work on business cycles in the Phillips machine back in the 60s, 70s, 80s, 90s. And I think if I just leave it, it will actually fall onto a Goodwinian business cycle. What it will do is it will hit the end stop. This tank is now full. The water will pour out of the back. And I think that corresponds to full employment. So we're now at full employment. So it should tootle along there at full employment at the top of this limit cycle. And if I just leave it going, it might take about 5 minutes. But by the end of the talk, this is fully opened, you see. Investment whooshed up right up to 4. We've got loads of investment. But now we've reached the top. So people are now going to say, well, hang on a minute, do we really want to keep investing? We're at full employment. And what you should start to see is eventually that will start to close again. And as it does so, after a while, this will then plummet. So we get the boom bust. So we can certainly do a boom bust. If I keep going, what will eventually happen is that my bucket will ground on the floor and it can't go any further. Now that I think corresponds in a Goodwinian sense to the lower bound is sort of zero investment. The zero investment, and you can't have negative investment. We can have a little bit of negative investment, which is depreciation, and you can even burn your machines, is that right, or something? So but anyway, there's a negative lower bound, whether it's zero or negative, and then it will go along, and then it picks up again after a while. I've been doing these lovely experiments. You can get these sort of relaxation oscillations on the limit cycles. Very similar to what Goodwin was saying, but it's based on this model of capital. And I think it's almost valid. I'm an engineer, I don't know if it's valid or not, but it's plausible for the boom. It's plausible while you're at the boom. The bust is even plausible. Going along the depression is plausible, but I think once we're along the depression, I then should disconnect the accelerator. Because once you're in the depression, there is no incentive to invest. And so you should disconnect the accelerator, it will stay there forever, according to this model. Whereas the machine will actually, because the accelerator, the hydraulic equations then diverge from the economic equations, the accelerator will pull it up, and you go on these 11-year limit cycles, which is very nice, 9 years, 11 years. But I think it's unrealistic. It's too sort of hopeful. It won't happen. You will be stuck on the bottom. But it's nice to get the boom-bust cycles without any government policy whatsoever. It just does it by itself, which is rather nice. So I'll just leave that going and think of some of the other things that I need to...
When the government starts spending money.
Or making cuts. In a Keynesian sense, I think that's when the government is meant to start making cuts. What I think you're meant to do is get the Franklin Delano Roosevelt speech, we have nothing to fear but fear itself. You stand in front of the machine and you read it to the machine, and then up it comes again. The inaugural address. I've done that in the past with A-level kids. It's quite fun to just sit and read. A fabulous speech. You all know it. If you don't, just read the words. Absolutely scathing of its view of bankers and people like that. Brilliant. Brilliant. When we were fixing this, one of my workshop technicians, he kept saying, oh, this is a calculator, Alan, where's the divide by zero button? And I thought this was a glib comment, but then one day I discovered it. When we first got this, there was only one graph that fitted here, and it had a 45-degree slope on it, which is a propensity to consume of 1, which is like me. You just spend everything. You don't save, you just spend, spend, spend. And I couldn't get the machine to settle down at all with this graph. It was the only one that fitted, it had to be right, and it just wouldn't settle down. If you made a little investment, it just whoosh, off it went. And we are fabulously rich. I thought, I've solved it. This is how we just be like me, spend, 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 and we'll all be rich. And it turns out that is the case in economics. There is a thing called the paradox of thrift, which says that saving is bad. Which was news to me. I thought saving was good. Every message I get from the media and the government says saving is good, whereas the paradox of thrift seems to say saving is bad. So anyway, a 1:1 slope, so the marginal propensity to save is 1 over 0, which is infinity. So there's the divide by 0 button, which gives you the sort of straight linear response that just grows forever. This experiment we did over here, where we did it with and without interest rates fixed, and we got very different results. I think, and this is an engineer thinking here, that I could do exactly the same experiment down here on the foreign sector with imports and exports, and the sterling balance is abroad over there. And I think, to my simple mind, that would explain why we aren't all fabulously rich with North Sea oil. That what we had was when the North Sea oil was found, we had a sharp decrease in imports, we could increase exports, and we should be going up, 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 but we're not, because the change in exchange rates erodes into it, and so instead of getting this, we got this graph upside down by the crowd in or out, whichever it is. Now, I've said this to economists before, and they've disagreed with me, but they've also disagreed with each other. So that's a simple view of possibly got something to do with this. But this also, I think there's a glimmer of hope, because if with the variable interest rates, there may be a way that the government cuts, instead of plummeting downwards, can be stabilised and they just go downwards a little bit. I don't know. I'm at the edge of the limit of my economics. All my economics is based on this, my understanding of this machine here. I got the money to do this summer. I spent fixing this from an organisation called Nesta, which is the National Endowment of Science, Technology and the Arts. They sponsored me as a water engineer to work on this one summer to fix it, and they get their money from the National Lottery. And to celebrate this, I thought I would add a little pipe from high street expenditure back to government as the National Lottery pipe, but they thought we wouldn't do this. It is also a work of art. The New Zealand one was taken to the Venice Biennale, and I think it was the year 2000. They took their Phillips machine from New Zealand and they juxtaposed it at the Venice Biennale against a New Zealand Land Rover and some New Zealand boxes of butter. Maybe it speaks to you, but it doesn't speak to me. The one in the Bank of Guatemala has become a sort of thing of myth and legend, and an artist about 2 or 3 years ago from the Tate Modern went to Guatemala on a quest for the Guatemalan Phillips machine, but he didn't find it, but he did find someone who had seen it 20 years ago, and that's all on the Tate Modern website if you go. It's a work of art, this man's quest for the Guatemalan Phillips machine. Of the 14, many of them have been lost. We know the whereabouts of 3 or 4. One was found in a cupboard at the University of Istanbul about 2 years ago in pieces. Most of them, some were dropped downstairs, we're aware of. Others, we believe the monetarists stole all the pieces. So I'm a mathematician as well as an engineer. One of the things I love about this is the way that it makes integration so simple. Integration for me is a load of Greek letters and squiggly symbols. And here Phillips makes it so clear. You integrate. It's like pouring water into a bucket. Here's the flow. Let's integrate it. You just pour it into the bucket. And to solve a differential equation by just integrating it, by pouring water in a bucket, I think is absolutely brilliant. The reason I'm interested in this is because I'm a water engineer. I teach the students water engineering, and I tell my students in water engineering, if you want to be a water engineer, you need to know much more than hydraulics and pipes and pumps. If you need to understand economics, go to economics lectures, go to sociology lectures, understand how the world works. If you want to work in India, you need to understand economics. There are people in this department who work on development economics, trying to get Nobel Prizes, etc. Any engineer knows that the way to economic development in these places is you start with sanitation. Start with the water engineering. That's what my PhD student's been doing in Ahmedabad. Let's put the pipes, the pumps, the sewers, the toilets into the slums of Ahmedabad and the megacities. People will get well, then they can get jobs, then they can be economically prosperous. So there's this fabulous interaction between water engineering and economics on every level. And this is just a complete flip side that said that the economists needed to understand hydraulics. But I really believe economists need to understand water engineering and sanitation and the good that it could do for economic development. So, oh, it's dropped, but I didn't move the paper. It's dropped, it's plummeted again. It has plummeted, it's plummeted from the 12. We're on the Goodwin cycle, but I've lost the exponential because I was too busy talking and I didn't move the paper. But it has plummeted. You can see investments shut right down. It's shut right off. This is shutting right down. It was at 7. Everything's collapsing. The machine is drying up. So there was the boom. We stayed at the boom for about 5 years, and then we just plummeted down, and we're now heading towards a bust. If I keep it going, we'll have about 5 years of bust, and then this will pick up. But in reality, it won't, because I should then disconnect the accelerator. I could, yeah, and that's what I would do, but then I'm not David Cameron or Nick Clegg or Vince Cable. That's what I would do, but then I learnt my economics on this machine. So, sorry? This would, yeah, this would, definitely, yeah. There's a fabulous book by Robert Leeson here, which is the collected papers of Phillips here, and there's also some articles. He only wrote 14 papers in his life, which is amazing. He nearly won the Nobel Prize. He would have got the Nobel Prize, but he died of cancer age 60 because of the heavy chain smoking. There's a picture of him on the front with a cigarette here. Cambridge University Press have very kindly given us 20 of these to give away for free. So would anybody like one of these? It's a fantastic book. Put your hands up if you would like one. Okay, they are not free, they are £65. Who would like... That is an example of a demand curve. Okay, they are £20 and they're available from the library upstairs. Okay, which should be somewhere about there. So there's 20 of these. But it is a fabulous one. There's the stories of him in his youth, etc., and so forth. And then there's all the work he went on to do with the Phillips curve and tried to apply control theory to stagflation, etc. But only 14 papers in all. And then a lot of fabulous articles by people who knew him, including James Mead. We're in the Mead room here. Mead won the Nobel Prize. Mead said, I only ever met one genius when I was at Cambridge. I met an awful lot of people who thought they were geniuses. But I only ever met one, and that was Bill Phillips. And it's been an absolute privilege to work on this machine and to show it to you today. So, thank you. Oh, one thing I haven't shown you quickly is this. It's just 1 second. I've just drawn this. This is for the engineers. The economists will not be interested in this, but the engineers will be amazed. Okay, everything we did today depended on that propensity to consume graph here. Okay, now the y-axis is income minus taxation. Now that's a flow. There's a beautiful dichotomy, what's a stock and what's a flow. It's really clear on this machine. That's a flow. How are you going to power the vertical axis of this off a flow? You can't put a big float on it like we could with all the other graphs. So Phillips has come up with an ingenious solution, which I've tried to sketch out here. So his income after taxation comes down here. So the first thing he does is he puts it into a small holding tank. At the side of it, there's a sutro weir. So this has no economic meaning whatsoever. It's just to measure the flow. He needs to measure that flow. Via the linearity of the sutro weir, we've got the head is proportional to the discharge. That head he measures with a manometer at the side here. That manometer's got one of these 240 volt water level sensing devices on the wall. The wires from that go round the back to a little motor around the back. No economic meaning whatsoever, purely engineering. People say it's off a Lancaster bomber windscreen wiper motor, but we're not sure about that. It's a bit apocryphal. That motor connects this funny little armature toggle thing, and when those touch the water it clicks this way, and there's a secondary auxiliary pump going round the back pumping water, and the water flows down this leg, turns this water wheel this way, which drives the worm gear, which drives the cog, which drives the pulley, which drives that, which turns that, which pulls that, which lifts it up. Absolutely breathtaking. And there's two of them, because there's also one on the foreign sector, so beneath this there's a whole extra separate arrangement, and that's how he powers that up and down there. Absolutely breathtaking piece of, it's just amazing. Any engineer will just be, and you can see it around the back. It took us a month to work out what on earth is this thing at the back until we could work out eventually that's what it does, and everything hinges on this working very, very smoothly. So we've been and lubricated it and check everything works. It's and it does, works beautifully. So that's just for the engineers. Okay, that's it, sorry. Over.